Okay, this is a review of structural induction, which you are sitting live in the video. So you can ask me a question. Okay, and the set S we defined as follows. Again, I'm given the recursive definition here. I'm given 7 belongs to S, and new elements are generated by either doing 5x plus 2 in S or x square minus 2 belonging to S. Now they want me to prove that use structural induction, prove that all elements in S has this property. X mod 10 is 7. But I don't know, how does this x mod 10 equals 7 works? How do I prove explicitly? How do I write this as an equation without the mod? I need to show mod 10 means when I divide by 10, I get remainder. This is the remainder, right? That x leaves when you divide x by 10. So this, in other words, this is also known as, in other words, this is x equals some multiple, but 7 is extra. 7 is a remainder. So you have to prove that every element of the set can be written in this form, 10k plus 7, right? So the mod thing is just another form, another variation of this equation, where k could be any integer, we don't care. Okay, k could be 0, positive, negative, doesn't really matter as long as it's an integer. Question clear? There are two cases again, because we are generating new elements using case 1, case 2. There are two formulas, how we are generating new elements. This is exactly how you're going to write the proof. So let's start with basis step. Basis step. Okay, the basis element is only 7. So I need to prove that 7 can be written, 7 belongs to S, right? Can I write 7 as this form right here? 10 times some integer plus 7. Can I? So 7 can be expressed in the given form that they want, the desired form they want, where 0 is an integer. So therefore, the base case satisfies the property, satisfies the desired property, which is we want the element to be in this form. Good, this is done. Just explicitly write it out or type it out in the proof paper and you're done. What about the inductive step? How do I begin the inductive step? Read the previous example. What did I do? I assume an arbitrary element is there in the set of the form yes. A slight correction here. This is not called the inductive step. That's for induction. This is called the recursive step because it's structural induction, right? Remember this. If I'm giving you the recursive definition, that's the recursive step. Okay, assume an arbitrary element. You're right, Carter. Assume X is an element of the set such that, oh, X belongs to S be an arbitrary element. We have to use all the buzzwords. Arbitrary element such that belongs to S. Be an arbitrary element. Okay, this is just be an arbitrary element such that X is of the form 10k plus 7, where k is an integer. So I'm assuming there is an arbitrary element which already has the desired property I want. That element is 10k plus 1. Now we will not do any simplification to this guy. This will stay. The next thing we do is move on to the formulas, to the cases that are given to us. In this question, I have two formulas which I'm using to generate new elements out of X, right? So I have to consider two cases. Case one. And this, you see the line breaks here? Case one, you have to write it out, bold it, underline it, all that you can do on canvas, okay? But have a new paragraph for case one. Case one, I'm going to consider the first formula. Consider 5x plus 2. Of course, you will be using this assumption in the proof. So what I'm going to do, I want 5x plus 2 in the desired form, which is right here. As you can see, I'm highlighting it, right? But how do I prove it? How do I get 5x plus 2 in the form 10k plus 7? I'm going to replace 5x with 10k plus 7. So this will be 5 times 10k plus 7 plus 2. What does that give me? Do some math. Well, this gives me 50k plus 35 plus 2, right? But I need a remainder of 7. How do I get that? How did I get this? Yeah, manipulate it. Can you get 10 times an integer plus 7 somehow? Can I rewrite it? This can be written as 50k plus 30 plus 7. All agree? Now can I take 10 common? So I got 5k plus 3 plus 7, right? And this is something I expect you to show in the proof. How you're breaking up your integers, how did you get the 10 common? But this makes sense, right? I started with 5x plus 2. I replaced the x with the highlighted part because that's our assumption. And then I manipulated somehow. So eventually I ended up with 5x plus 2 in the form of 10, let's call it q1 plus 7, where whatever your q1 is, 5k plus 3 is an integer. And I'm done. My 5x plus 2 is in the desired form. But am I done here? Is the proof done? Nope. I have one more formula to deal with. I have to start considering the x square minus 2. So same thing, same manipulation you will do. Case 2, I'm going to consider the second way we are generating new elements. Again, the strategy will remain the same. Replace x with 10k plus 7, because that's the assumption. You have to use your x element that you assumed. Okay, now do this math. This is not going to be easy by any means. But let's open this. This will be 100k square plus 49 plus 2 times 10, 20 times 7, 140k minus 2. Okay, I need a plus 7 and everything else should be a multiple of 10. Okay. So I'm going to simplify. Can you do that? Move things around, play with this. I need a plus 7 at the end and a multiple of 10. So I'm just going to keep the 100k square plus 140k together. And 49 minus 2 is 47. Okay, this is easier than I thought. This will be 100k square plus 140k plus 40 plus 7. You see why I broke it up? Because I need a 7 in the desired form. And the rest of them I can take a 10 common. So my x square minus 2, which I did all this math that you see here, right? And I got 10 common, and I got 10k square plus 14k plus 4, and then I got plus 7, right? Now this number looks huge, so I'm going to, it is an integer because k is an integer, so this number has to be an integer. I'm going to replace it with another integer, say q1, q2, right? Because I already used q1 above. So I started with x square minus 2, and I got the desired form, what they wanted. q2 is an integer, where q2 equals 10k square plus 14k plus 7 is plus 4, my bad, is 4. You have to tell me my mistakes, okay? Plus 4 is an integer. So this is the core part, right? Base step, I proved that the parent element, the starting element, can be written as 10 times something plus 7. Then I started with recursive step. I assume an arbitrary element. I prove both cases. Am I done now? I'm missing something? Closing statement. Therefore, by principle, and that starts a new paragraph in your proof, right? By principle of structural induction, all elements of the set, all elements of the set S are of the form x equals 10k plus 7, or you could say also x mod 10 equals 7. They mean the same thing. X mod 10 equals 7 means you get remainder 7 when you divide by 10. In other words, you can rewrite it as an equation. The equation form is more useful. Now you have to type this proof out. I'm going to share this PDF for a minute here. And the questions can be like this. Like you have to find the mistakes in the following proofs, right? You cannot find the mistake unless you write proofs on your own, match them with the lecture notes, and find your mistakes first. Because then and only then you will be able to find the mistakes in the multiple choice questions. Now I want to find a proof where we write a nice proof for you. Yes, exactly. Right? I have a bunch of proofs here that I highly recommend you to see. Okay, and read through this. Don't just read through this. A good proof. There you go. A good proof, you start with this is exactly how you want to type. The initial population or initial step, which was 7, has the form. You can write it out. Recursive step. You have cases. In this case, there was only one case, but sometimes you'll have 2 or more. Okay, so you prove for each case that the resultant element has the form. And then you closing statement. So these are more nicely formatted, right? This is exactly what I want from you. Okay, this is it. Let's just, okay, I cannot minimize this. We want to end this meeting.